Hi my fellow planners, I'm the Rational Planner, and before moving on to CoPPGIS soon, I wanted to make this video as a sort of sidestep to the main discourse. My exams are coming up and I wanted to compile some tricky stuff my class has given me by learning through teaching. So, in this video we will speak about life tables and everything else to do with demographics such as demographic rates and fertility. Life tables are used to gain an estimated projection of a cohort of people, such as a group of people born between or on a specific year. Project it into the future of their, amongst other things, survivability. We will also look at demographic rates and other things to do with how censuses are calculated. The columns of a life table appear across as death, D, population, P, ASDR, or age-specific death rate, as M, average time to death in the interval, or A, probability of dying between exact ages, Q, probability of surviving between exact ages, P, numbers surviving at exact ages, L, deaths between X and X plus N, this is the present and future, as D. This is being the deaths that occur from the starting year X and the number of years after. Then L, the person years lived between X and XN, and T, the total person years lived between X and over. And finally you have E, which is the mean expectation of life. These life tables are produced by those either of the World Bank or usually the World Health Organization or WHO. Additionally, countries may also perform their own poll through census, such as Australia's ABS, which is our Australian Bureau of Statistics, performing a similar function. So now let's do an example of where we may use this life table. Using the 1999 Russian life table for males, select the probability of a newborn to die before his 65th birthday. From this question we are trying to find the probability of a newborn dying before age 65. So we know that the initial starting age X is 0. We also know that our final age is 65. This will be our X plus N, meaning X in the future. So now we must think as to which column we need to use, this being either M, Q, L, or E. We know we want as a final answer the probability, so you may lean towards using Q, which appears as NQX in the table. But this is not right as they are already in percentages. We need figures to work with. So we will instead use LX, the numbers surviving between exact ages. We can then simply solve for those who died, and then put this over our starting number for a percentage. So in doing this, we will write 65 P0 equals L X plus N over LX. So getting our age 65 corresponding cell in the LX column, we get 52,953. With our age 0 corresponding cell, we get 100,000. This leaves us with a value of 0.5295, which is 52.9%. This is the percentage still living. So taking this away from those 1 or 100%, we are left with only the dead individuals. So this would be 1 minus 0.5295. The chance of a newborn will die before age 65. This equals 0.4705 or 47.05%. Be mindful that this is in Russia, so you're lucky if you make it past this point. If you make it to age 65, you're probably going to die before that point. So you've got a 47% chance of dying before 65. Next, we're going to look at something similar, and this is measuring population change. But first I must notify you, the viewer, of something to grasp beforehand. This is demographic rates. Demographic rates are the relationships between demographic events and the number of persons at risk to that event during a time period. So we'll just say the event is the time period. So an event may be, say, 0.5 years, which will be 6 months. Given the following image, we can clearly see two demographic events, or our numerator as deaths. Secondly, we can see two people not at risk to the full spectrum of whatever the demographic event was. In years or months, here we're using years. So although we have 8 horizontal bars, 8 people pretty much, only 6 of them suffered full exposure to the time frame, to the event. This is our denominator. So our answer for our demographic rate, or deaths in year T, to person years at risk in year T, is 2 over 6. And then we do times 1,000, as this value is per 1,000 people, equaling 0.33% of people were at risk. Sorry, I had to add that. I might also mention here that if you're confused by these numbers on the side, just realize that they are essentially as a percentage per year at risk to the event of time. So for example, the topmost bar has a value of 1 or 100% because this person, the topmost bar, they suffered full exposure. They were there throughout the entire time period. Whilst the second topmost bar has a value of 0.5 or 50% because they died before experiencing the full 100% of the event. Bloody lucky immigrants, I bet you're probably thinking. So, talking about demographic rates, we may continue this chain of thought by getting into very briefly direct and indirect methods of measuring migration. In the direct mode of measuring migration, we would simply check the National Register for a change in residence. These may be broken down into both events and transitions. Now, events are essentially the movement a person has conducted, whereas a transition is only recorded if the destination reached by a person is indeed the last point moved to. So, given the third example, we can clearly see that a person moved a number of times, but they only settled for 5 years, as clearly labeled by T+5, once. For example, this person could have transitioned from Sydney to the Bahamas for a week, and then Rome for maybe 2 weeks, and then actually immigrated and settled in New York for, say, 3 years or something. Hence, events 3 and transitions 1. There are also indirect methods of documenting migration, and this is through, wait for it, Lifetables. Shit. Migration is estimated as a residual after accounting for other components of population change. So looking at this table, estimating net migration, we would identify net migration here by doing the following. Get a population in intervals, here in 5-year intervals. Estimate how many will be alive by the next interval, 5 years from now, by multiplying the survival ratio by the populations. Thirdly, this estimate is in column D. We can see that we start a row down for this column because those aged 0 to 4 are now starting age 5 to 9. So there is no 0 to 4 age bracket anymore because they've moved up a bracket. So in the fourth step, get the actual surviving population, column E, and then step 5, net migration, column F, equals column E minus column D. The actual surviving population minus the estimated surviving population. Geez, okay. Let's just sweep all that crap now under the rug and move on. Now back to measuring population change. The formula for this appears as the following. You can use any 3 of these, annual population or rate, or annual average rate of population growth, depending on whatever it is that you need to do. They're pretty straightforward. And I shit you not, but this is the easiest part of this whole damn video, which is why I intend to not waste another fleeting moment on it. In addition to this, we have the overarching demographic equation, which you can see right here. There's an example of it as well. So just go ahead and read that. It's also pretty straightforward. And with this formula, we could easily calculate the future population using the current population and its factors. Or you could use, if you've had it, you could also calculate, say, the immigration or the emigration if you had the future population and the current population, which I guess would be actually the former population if you were trying to find immigration or emigration or something, or maybe births and deaths. And finally, I want to go over one last thing with demographics, so bear with me. This is fertility. So given the following question, we must work out the TFR, or the total fertility rate, the GRR, or the gross reproduction rate, and the NRR, or the net reproduction rate. And these three have three specific differences, which I'll go over. If you ever done the total fertility rate, you may have seen the others but not know how to actually calculate them. This I'm going to help you with. So the TFR, or total fertility rate, is calculated using the following general rule. Take the ASFR, which is the second leftmost column, age-specific fertility rates in 2001, for each age and sum them. So sum up the ASFR column to get a summed value. Secondly, multiply your answer by the age group's range. So if you look at the age group column, you see like 15 to 19, and this is the value of 5. Note that this includes the value of 15 as well, so we count it as 15, 16, 17, 18, 19, so 5 in total. So, again, we're getting our sum from the ASFR, and we're timesing this by 5. We then divide this answer by 1000 to give us our TFR, which is usually, depending on the country, this can vary significantly. It'll usually be between 1 and 3. So Australia is like I think 1.8. So if it wasn't for immigration, our population would be decreasing, because you need to have a total fertility rate of 2, which is the replacement amount. So if a mother and a father... Hey kids, I'm going to tell you about the birds and the bees. No, if you have a mother and a father, if you have a mother and a father, and if they don't have 2 kids, then that means if you have less than 2 kids, say if you have 1 kid or no kids, then those 2 parents are not going to be replaced in terms of population. So the population will decrease. If they have more than 2 kids, population will increase, and the TFR will be greater than 2. So this value is the average number of children born to any single woman. Note that this is children and not daughters. This is what screwed me up learning it, and this is why I'm going over it in this video. So that's our TFR, but what about the GRR, or gross reproduction rate? Well, our GRR is calculated thusly as the same thing as TFR, but using only daughters. Obviously, we don't have an ASFR only daughters column, we only have the ASFR. So do the exact same thing as before, except first, take the ASFR values and multiply them by the proportion female births, or the bottom row, as 0.49. Then do the same as before by multiplying by 5 and dividing by 1000. So again, get the ASFR times each row, so 17.6, 57.6, and 110.5, etc., times 0.49, and then you have all new values. With all these new values, add them all up, so sum them, then multiply by 5, and then divide by 1000. And that is your GRR, or gross reproduction rate, value. Finally, we have the NRR, or net reproduction rate. Again, this is the same as before, using only daughters, with the exception of also adding mortality to this, and using the adjusted ASFR. So, using the rightmost column instead of the ASFR that we used previously, the second left column, we're now using the rightmost column. Multiply this by the proportion female births, so do the exact same thing that we did with the GRR, to give you new values, and then multiply these new values by the survival ratios. So effectively, we're getting the adjusted ASFR per 1000. We're timesing this by the proportion female births, so we're getting only the ASFR for daughters, and then we're multiplying these values by the survival ratios. So we're only getting the daughters that survive of the ASFR. So then you want to finally again do the exact same thing as the TFR. You want to multiply, sum these up, and then you want to multiply them by the age group range. Ours is 5, and then again divide by 1000, and that's your net reproduction rate. Okay, thanks for listening to this video on demographics. Yes, I know I missed mortality, which goes into a bit more, but I'm still kind of in the middle of learning it myself. So once I figure it out, if at all, I'll do another video on that later. But I'll leave you with this one small thing I thought I'd leave on the screen as a sort of a send-off. So good luck guys, and don't forget to give a like and subscribe. Hopefully my channel can get noticed and I can help more people in demographics, as annoying as it is and as problematic as it is. So anyway, good luck to you guys, and whenever I choose to make another video, hopefully you guys will see that one as well. So good luck.